Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Anandi, Pune. Today's our discussion topic is Generative Adversarial Network. This Generative Adversarial Network, that is a GAN, are exciting recent innovation in machine learning and deep learning. These GAN are generative models. They create the new data instances that resemble your training data. Now these are the images are generated by the GAN model. Now if you are giving the input into the for the image in the form of noise, and then you can use in backpropagation algorithm, you can revise the images to generate the fake image. Now here, generative adversarial network consists of two modules, that is a generator and discriminator. This generator takes the random noise as an input and generates the realistic data for fooling the discriminator, and whereas the discriminator classifies the input image as a real or fake. Now whatever images are generated by this generator, these image will be classified into two classes, real class and fake class, distinguishing the genuine data from generator's input. The generator and discriminator are trained simultaneously in game theoretic manner, improving the iteratively as they are trying to outperform each other. Let us discuss the background behind this generative model. That GAN, that is generative, refers to model to create a new data instances resembling the original data by capturing the joint probability, that is a p of x comma y or p of x if label are absent. Generative model, generally these are the unsupervised learning model, but whenever we are using the training data set, at that time for generative phase we are using the unsupervised learning model to generate the new images from the noise data. Now generative models contrast discriminative models, which focus on the distinguishing between the data types by learning the conditional probability p of yx. This generative model generate the realistic data, whereas the discriminative model classify the distinguished data instances. Generative model provide the probability distribution of the data, that is the probability of generating the images, new instances, while discriminative model focus solely on the label prediction, that is a classification of fake and real images. These generative models are hard because these generative models handle a more complex task than discriminative model because it is generating the images, whereas the discriminative role is only for classifying the images. This generative model focus on modeling the full data space, capturing the detailed pattern and relationship based on the performance and the feedback received by the discriminator. What are the loss generated by the discriminator? Now based on this performance of the or acknowledgement by the discriminator, generator trying to improve its performance. Now let us discuss here one example that this is the discriminative model and generative model. In discriminative model means whatever images are generated, here these images are classified into different classes, two classes, real and fake class. But the generative model tries to produce the convincing ones and zeros are generating digit fall close to their real counterpart in a data space. Discriminative models are used for supervised classification, whereas the generative model used as a unsupervised model. Let us consider one example, classifying handwritten digits from 0 to 9 label dataset, which is used each image paired with its corresponding digit label. The model trained to minimize the loss function and learning probability distribution of the output digit given input. In mathematical term, the discriminative model, conditional probability y of x, that is where y is the output digit and x is the input. Here you can see this is the training sample. In discriminative model, by accepting the input which is generated by the generator and classifying, that is a prediction phi. Either it will be classified into fake and real, or it will be classified as with respect to the label. Opposite to discriminator, generative models like GAN are trained to learn how data set is generated by modeling the underlying probability distribution. They are often used with unlabeled data set are considered in the form of unsupervised learning. During training, the model adjusts the parameter, minimizes the loss function, and learn the data distribution. The generated data is based on a random sample from latent space. That latent space, that is which will hold the encoded information in the form of compressed data distribution. Now here in generated, the training sample is given here, then based on the random data, input is given to the generative model and it will generate the sample images. Means it will give the random noise. These are the sample images. Sometimes the training data set is not available. If training data set is available, means it is the supervised model. If we are not using training data sample based on the random data and based on the feedback given by the discriminator, the generative model tries to improve the quality of new generated image. Now let us discuss the overview of the GAN structure. This generator learns the generate plausible data, and generated instances become negative training example for discriminator. As the discriminator learns to distinguish the generator's fake data from the real data, and discriminator penalizes the generator for the producing implausible result. Based on this penalty, the generator trying to improve to generate the and generating the images which will look like the original image. When training begins, the generator produces obviously fake data, and the discriminator quickly learns to tell that it is fake. Finally, if generator training goes well or after number of epochs, discriminator gets worse at telling the difference between the real and fake. In this case, the discriminator loss is more and generator loss will be less. Now here you can see this is the generated data. Initially in generated data, after epoch, then this image is generated by generator, then discriminator role is represent, that is it is fake or real. These are the label data, then these are the at the end after few particular epoch or if iteration, that image generated by generator will be similar to the real image, and in this case discriminator falls to identify the difference between fake and real generated image and real image. This is the architecture. In this architecture you can see random input will be given through generator, the samples will be generated, these samples output will be generated, and here this sample image will be passed through the discriminator will classify based on this real, compare it a sample generated by generator with the real data set. If it is fake, then display the output, if and otherwise real output will be displayed. Discriminator generate two loss, that is one is a discriminator loss and two second generator loss. These are the evaluation metrics for your GAN model. If generator generating incorrect image, that in this case generator loss will be less. If discriminator giving the incorrect result to differentiate between fake and real image, then this loss will be more. Now in discriminator, we are using the back propagation based on this value. Then in back propagation, the weights are updated for both model, and here generator based on the feedback received by the discriminator. Again in every iteration, update the weight, and after apply after back propagation algorithm tries to improve the result of performance to generate the images which will look like real images. Discriminator of GAN is trained using two types of data. One is the real-time example and another is the fake data generated by generator. During this phase, generator weights are remain fixed, and it only produces the data for the discriminator to classify. Discriminator has two loss function. Already we have discussed in previous diagram. One is a discriminator loss, which penalizes the discriminator for misclassifying the real data as a fake or vice versa, because at the end what happened after optimal number of epoch, discriminator loss will be more. Back propagation is used to update the discriminator weight based on the loss, and this discriminator is not trained during this phase. Now here let us understand how we are passing phases, one by one phases in GAN model for during training. Random noise is sample passed through the generator to produce the data. The discriminator classify the generated data as a real or fake. Loss is calculated based on the discriminator classification, and backpropagation adjusts the generated weights by calculating the impact of discriminator feedback and while keeping the discriminator weights fixed. The cycle is repeated to train the generator, improving its ability to fool the discriminator. Initially, the discriminator loss will be more and generator loss will be less. Discriminator loss will be less and generator loss will be more. But eventually, what happened progressive whenever we are iterating this model, backpropagation adjusts the generator weights and generator loss will be less and discriminator loss will be more. Actually, in discriminator and generator model, we are using two algorithms that are called as downsampling and upsampling. Now here, downsampling is also called as convolution and upsampling is called as deconvolution. Now here you can see downsampling is similar to the CNN. Means in generator we are in and discriminator we are using the CNN, convolutional neural architecture, but in in generator we are using upsampling. Upsampling means based on this, suppose this is the noise, based on this noise we are creating the feature maps, okay, and creating the new data set. But in discriminator we are using convolution model by downsample model. Okay, now in downsample we are reducing the size of feature to classify the images. Here we can see, now this is the example of downsampling and this is the example of upsampling. Downsampling, this is the feature map which is used in discriminator for classification. This is the 6x6 matrix. Then here we are applying the max pooling and generate the max pool feature. This is downsampling. But opposite to the downsampling, upsampling, which is applicable, employed for the generator. In generator we don't have image. Now in this case we are creating the noise matrix and we are expanding this matrix to write the patterns of the images. Okay, repeatedly this process will be generated and generate the feature map. This is called as the upsampling. Now here one of the example of generative model. In this example, this is the example to generate the images, handwritten images. Now this is the fake noise used to generate the image, and these are images. After a few iteration this image is generated. This is the fake image that will be compared with the real image and discriminator display the output just the image is real or fake.